What's the flux through the coil when there's no current? Zero. Nature wants that to stay the same, just like it wants a mass's velocity to stay the same. So when you try to close this switch and try to get current going, notice that the EMF that is produced opposes the source EMF.
While current is increasing.
And that is what the meaning of this thing right here is, why I've given this thing polarity. It's positive on that side and negative on that side, because it is opposing our source EMF. And that's what inductors do. They will oppose any change in current. And let's take a look at this. We've seen a couple ways to look at inductance. One of them is just the definition of inductance right here. It's the magnetic flux per ampere. The way it fits into our back EMF equation right here, it is the back EMF is negative L di dt. It's the inductance times the rate of change of current. Here's even another way to look at inductance or self-inductance. It is the ratio of back EMF produced per unit change in current per unit time. That's a mouthful. Let's look at this. Di dt. What units would that be measured in? Amps per second. It is a rate of change of current. So you tell me this. If you get 10 volts of back EMF, if the current is changing at a rate of 2 amperes per second, what kind of inductance would do that? Give you a back EMF of 10 volts as long as the current is changing at a rate of 2 amperes per second. What's the numerical value of the inductance? 5, but what are the units? Here we go. Units of inductance are called henries. 1 Henry, or 1 H, is simply a Tesla meter squared per ampere. Or another way to look at it is a Weber per ampere, or a volt second per ampere. The reason it's a volt second per ampere, it's really a volt per ampere per second. 1 Henry of inductance gives you 1 volt for every ampere per second of change. If you don't have a change in current, you get no EMF. You get no back EMF. So an inductor of 1 Henry simply gives you a volt for every ampere per second of change.
You can see that a Henry may also be interpreted as a Tesla times meter squared per ampere. In other words, a coil that has an inductance or self-inductance of 1 Henry will produce 1 Tesla meter squared of magnetic flux for every ampere that's traveling through the coil.
If you want your inductor to give you a DC voltage, what do you got to do to the current? Keep increasing it or decreasing it forever at a constant rate. So you'd have to have a linear graph of current. That gets really difficult to keep the current increasing forever.